Happy Math Hour. Today I'm going to cover Exam 3 review, which is, I believe it's Chapter 6. Okay. These are the topics that Exam 3 will cover. Section 6.1, 6.2, all the way to 6.6, which is really solving system linears of equations and also matrices. Okay, so let's start with question number 1. Here it says, determine whether the given order list of numbers is a solution of the system of equations. So here, what the objective is here is to plug in -1 for x and 3 for y on the left side of the equation for x and y. And if the left side equals to the right side, then it is a solution, but it has to be true for both equation 1 and equation 2. Okay, so I call the first equation equation 1 and the second equation 2. So let's first start by plugging in -1, 3 on equation 1, -1 for x and 3 for y. Okay, after we simplify, it's going to give us -2 plus 3, which is equal to 1 equals 1. So this one is true, right? If it's true, then we continue to equation 2. If it's false, we stop there and then we say it's not the point is not a solution. But since this is true, we continue to equation 2. And again, we're going to plug in -1 for x and 3 for y. So this will give us 3 plus 6. So 3 plus 6 is 9, so 9 equals 9. That means that that this order pair, -1, 3, since it makes both equations true, this is a solution. This point is a solution to the systems of equations. Okay. Now, let's repeat the process for question number 2. For problem 2 here. Again, we're going to plug in 2 for x and -0.5 for y. So equation 1, I'm going to plug in 2 for x and -0.5 for y. This gives us 1 minus 4 equals -3. So this is also true, correct? So then I have to continue to plug in the point to equation 2. And if it makes it true, it'll be the same thing as number 1 here, where the point is a solution. This point here. So let's check by actually plugging in the value for x and the value for y, which is 2 and -0.5. Okay, so we plug in the value 2 for x, and we plug in the value -0.5 for y. This gives us 2 minus 2.5, which is -0.5 equals to -5. That's not true. So in other words, if it's not true, then the order pair 2 -0.5 does not make both equations true. Then the order pair is not a solution. So number 1, yes, a solution, and number 2, no, not a solution. Okay, this is kind of straightforward. All we have to do is plug in the values, and that's it. Now let's go to number 3. Number 3 is plugging in. It's graphing, solving the system by graphing. Okay, so let's start with equation 1. So let's graph equation 1. Equation 1, the slope is 3, 1, right? 3 over 1. And the b, which is the y-intercept, is 0, -6. And the b, this point, the 0, -6, is always your starting point. So I'm going to start here at 0, -6, which is right there. Then the slope is 3, 1, right? So I'm going to go up 3, 1, 2, 3, and 1 to the right. There's the other point. You see, guys, and if I continue 1, 1, 2, 3, 1, 1, 2, 3, 1, eventually the line leads to all those points. You see, 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1, and so forth. But to graph a line, we only need 2 points. So 2 points is enough. Okay, that's how you solve by graphing. Now I'm going to do the same system of equations, but now I'm going to solve it by substitution. Okay. Oh, no, hold on, guys. My bad. I have to do also equation 2. I'm sorry about that. After you graph equation 1, then you have to graph equation 2. So we're going to do the same thing, but equation 2 is not in slope-intercept form. So the first step is to put equation 2 in this format, y equals to mx plus b. right? So we're gonna add 5 to both sides. I mean 5x to both sides. So it gives us negative 2y equals to 5x minus 10. Then I'm going to divide both sides by negative 2. That will give us negative 5 over 2x plus 5, because negative 2 divided by negative 2 will give us a y. 5 divided by negative 2 will give us negative 5 over 2x. And negative 2 divided by 10 will give us positive 5. So then we have equation 2 is the same equivalent, but this is in standard form. This is in slope-intercept form. So from here we get my slope, which will be 5 down and 2 to the right, from the y-intercept, which is 0, 5. So this is my starting point, 0, 5, which will be about right there. Okay. Now I'm going to go down 5. 1, 2, 3, 4, 5, and 2 to the right. 1, 2. So if we draw that line between the 2 points, this is a line. So for graphing, so for solving systems, when you're graphing, you have to find out where the points intersect. So this is my answer, which is 2, 0. Okay. The solution is 2, 0. 2 for x and 0 for y. Now, like I mentioned earlier, I'm gonna solve the same system, but I'm gonna do it by another method, which is called by substitution. The substitution method, the objective is to have one of the variables isolated. Since y is already isolated in equation 1, I'm gonna plug 3x minus 6 on equation 2 for the y value there. Okay. So substitute 3x minus 6 for y. Yeah, so I'm going to plug it in here, right, for y. Then I'm going to distribute. So it'll be negative 5x. Negative 2 times 3x will give us negative 6x, and negative 2 times negative 6 will give us positive 12. So then we have negative 6x minus 6x plus 12. Then we're going to combine like terms, which will give us negative 11x plus 12 equals negative 10. Then after that, we have to subtract 12 to both sides. Right, minus 12 here, minus 12 there. It'll cancel on the left side. Negative 10 minus 12 will give us negative 22. So we get negative 11x equals negative 22. Now we divide both sides by negative 11, and we get x equals 2. Once you find one of the values, either x or y, then we have to plug into the other one, okay? So here we're going to plug in either to number 1 or number 2. So in other words, I'm going to plug in 2 for equation 1, right, for the x, or equation 2 for the x over here in equation 2. But it's easier to use equation 1. Why? Because the y is already isolated. So when we plug in the value for x, we got a response for y. Okay, so we're going to plug in 2 for x. So 3 times 2 is 6. 6 minus 6 will give us 0. So y is 0. So when x is 2, y is 0. So that's my solution, 2, 0. Now, there's another way to solve. This is called by the elimination method. So I'm going to use the same, no, I believe this is a different one. Okay, solve by elimination. So to solve the system by elimination, I have to put in both in the form ax plus by equals c. Equation 2 is already in that form, but not equation 1. We need to rewrite equation 1 in proper form. So here, guys, I'm going to add 2y to both sides. They'll give us x plus 2y equals 19. Now it's in proper form because it has to be in the form of ax plus by equals c. So again, this we rewrote equation 1 in the proper format, which is x plus 2y equals 19. And equation 2, we just bring it down. Okay. Now we need to eliminate the x's or the y's. It doesn't really matter what's easier for the student. In my opinion, it'll be easier to get rid of the x's, because to get rid of the x's, I just multiply equation 1 by negative 4. See? Because negative 4 times x will give me negative 4x. Then when I add them, they'll be eliminated. Okay, but I have to multiply negative 4 times every term, which will give us negative 4x minus 8y equals to negative 76. And how did we get this new equation? Was by multiplying negative 4 times x, negative 4 times 2y, which will give us negative 8y, and negative 4 times 19, which will give us negative 76. Equation 2, we just bring it down how it is. Now we add them, right? So that the x's will be eliminated because negative 4x plus 4x will give me a 0. But negative 8y minus 11y minus 3y will give us negative 11y. And negative 76 minus 1 will give us negative 77. Now we divide both sides by negative 11. And the result is y equals 7. Now I need to go back to either 1 or 2, equation 1 or 2, and plug in y. Plug in negative 7 for y and solve for x. Whatever is easier for you. In my opinion, it's easier to go to equation 1. Why? Because equation 1 is already isolated, right? We already have the y by itself. So we're going to use equation 1. So I'm going to plug in the 7 for the y here, which is right there. Negative 7 times 2, negative 2 times 7 will give us negative 14. Negative 14 plus 19 will give us x equals 5. So what's my solution? The solution is x equals 5 and y equals 7. So this is where they both intersect. So that's my answer for number 5. Okay? And now, again, number 6. I'm going to solve it also by the elimination method. Okay, so here, guys, I can get rid of the x's or y's. It doesn't really matter. So here, I'm going to get rid of the x's, which by multiplying by negative 2. So negative 2 times 3x will give us negative 6x. Negative 2 times negative 2y will give us positive 4y. And negative 2 times 4 will give us negative 8. And equation 2, which is bring it down, is going to give us 0 equals 0. So this means it's going to be infinite solutions. Okay? Because this makes it true, and we will have no more variables. So if they're equal, right, it's going to be infinite solutions. That means it's going to be a line on top of a line. Okay, that's what I went over, I believe, last week. Now let's see on number 7. On number 7, also we're going to solve by elimination method, which I'm going to get rid of the x's, which I'm going to multiply by negative 3. The first equation 1 by negative 3. It's going to give us negative 6x minus 15y equals to negative 24. And that I got it by multiplying negative 3 times every term here on the first equation. Equation 2, we just bring it over. Then when we do the addition or the operation, it gives us 0 equals negative 6, which this is not true, which means this will have no solution. In other words, these two, if we graph them, it will be lines that are parallel. So this is no solution. Okay. Now, how does this work? Like in a real life applications problem. Okay. So let's see how it works. This is number 8. A 200-seat theater charges $8 for adults and $5 for children. If all seats were filled and the total ticket income was $1,435, how many adults and how many children were in the audience? Okay. So here, guys, what's my strategy? I need to find two equations. So I'm going to go seats with seats and money with money. What does that mean, seats with seats? I'm gonna let x equal to adult seats and y equal to children's seats. And how many number of seats are there? There are 200. So it's going to be x plus y equals to 200. That's my first equation. Now money with money, right? So if the adult tickets is 8x, is 8, then the adult tickets will is going to be represented by 8x. Because adult tickets was what we use for x seats, and the children's tickets we use the y. So this will be 5y. And what was the total income? Was $1,435. So it's going to be 8x plus 5y equals 1,435. So this is equation 2. So I found both equations, equation 1, which is the x plus y equals 200, and equation 2, which is the 8x plus 5y equals to 1,435. Okay. Now we can solve them by either by graphing, which I don't recommend, because for that one the numbers are too high. We can do it by substitution, which some students might want to do that. But instead, I'm going to do it by the elimination method. Why? Because the two equations are already on the form that we need. The form ax plus by equals c. So here I'm going to get rid of the x's by multiplying the first equation by -8. -8 times x will give us -8x minus 8y equals to -1600. And equation 2 stays how it is. So after we do the operation, it's going to give us -3y equals to 165. We divide both sides by -3, and the result is y equals 55. So I found the value for y. Now I need to find the value for x. Remember that the y represents children's tickets, and the x represents adult tickets. So again, I can go back and plug them in on either one. In my opinion, it's easier number one because the numbers are much smaller. So when y is 55, I'm going to plug it in there, right? X equals, I subtract 55 to both sides, x equals to 145. So x equals to 145 and y equals to 55. So there's going to be adults, right? Adults are the x value represented by the x value, so it's going to be 145 adults and 55 children. So this is how many adults are in the theater and how many children are in the theater. So the answer is 145 adults and 55 children.
Mr. Zassi, you have someone with a question?
Yes.
I wanted to know, where did we get that -8 from? Is it...
Okay, hold on. Let me go back, okay? Let me go back. You mean this one here?
Yes.
Okay. What's your name?
Maritza?
Marisa. Check it out, Marisa. You can get rid of the x's or the y's. Okay? Let me start again on this PowerPoint. On this slide here. Okay? Let me end the show and start over here on this PowerPoint. On this slide here. Okay, that way I can explain it to you.
Okay. Thank you.
Okay, now, okay, let me go a little bit faster here. Okay, let me get to the point there. Okay, you're okay up to here, right?
Yes.
Okay, now check it out, Marisa. You can get rid of the y's if you wanted to. It's up to you. If you want to get rid of the y's, right? If this is 5, this has to be -5, correct? Because -5y plus 5y they'll cancel.
Okay.
If I want to cancel the x's, right? This has to be -8, correct? Because -8 plus 8 will cancel. Does that make sense?
Okay. Yes, it does.
So you do whatever's easier for you.
Okay.
So in my opinion, right, since we always get rid of the x's first, well, that's what I did.
Got it.
And then we multiplied -8 times every term here. Are you with me?
Yes.
Okay. Did I answer your question?
Yes, thank you.
So can I go to the next slide? You okay?
Yes.
Okay. Hey guys, and keep asking questions. Okay. Just raise your hand up, and then Patricia will let me know, and then I will explain it until you're satisfied with the explanation. Okay. I believe that's what we state. Let's go back over here. Here we go. Okay. Now we're going to be solving larger systems of equations. So here we have equations with three different variables, x, y, and z. Okay. Equation 1, equation 2, equation 3. And I believe last week on the PowerPoint that I presented in the workshop, I showed you guys a plan. Okay, here guys, because lack of time, I don't have a time to show you the plan, but I can demonstrate the plan. The plan is that I'm going to get equations 1 and 2 and get rid of the x's. And then I'm going to get equation 1 and 3 and get rid of the x's. So after I do this here, guys, the operation here, I'm not going to have no more x's. It's going to be something y plus something z equals to something. Okay? Let me show you what I mean here. So here, I'm going to get rid of the x's, right? So I'm going to multiply this whole line, this whole equation by -2. And again, why -2? Because we want the x's to be eliminated. So -2 times x will give us -2x. -2 times -3y will give us +6y, and -2 times 2z will give us -4z, and -2 times 0 will give us 0. And we just bring down equation 2. If you notice, right, after we add them, that will be 0. This will be +4y minus 3z equals to 3. So this is like my new equation 2. Now, to continue with the plan, I'm going to get equation 1 and equation 3 and repeat the process again. I'm going to get rid of the x's. But in this case, I'm going to multiply equation 1 by -3. And Marisa, to further answer your questions, you can do that in math. In math, it is legal. But as long as you multiply both sides of the equal sign by the same number. Or in other words, you can multiply, if you have an equal sign, you multiply the same number times every term. And that's legal in mathematics. Okay? So in this case, multiply by -3. So multiply -3 times x, -3 times -3y, and -3 times positive 2z, and -3 times 0. So this is my result. Okay? And then equation 3, we just bring it over, and then we do the operation. It's going to cancel. Y is going to be eliminated, but we're going to get 10y minus 7z equals 7. This will be my new equation 3. Now I'm going to get these two equations, right? And then I'm going to get rid of the y's. That's the plan. Okay, so here there's no easy ways to do it, but anyway, here guys, you multiply 20 is my LCM, right? My least common multiple that both can go into. But a lot of times students they don't know that 20 is a smallest number that these both can go into. So that's why I don't explain it that way, because it's more work for the student. Instead, if you know how to do it that way, more power to you. So do it that way. But here, I'm assuming that you guys don't know nothing this way. I can pick everybody up at the same time. So what I'm going to do here, guys, I'm going to multiply equation 1 by -10 and equation 2 by 4. Why is this? Because -10 times 4 will give us -40, and 4 times 10 will give us positive 40. Then when I add them, they'll cancel, or it'll be 0. Okay, but like I repeat earlier, I need to multiply -10 times both sides of the equal sign. So if I do that, it's going to give us -40y, -10 times -3z will give us positive 30z, and -10 times 3 will give us -30. And in the same fashion, I'm going to multiply 4 times every term in equation 3. And I get 40y minus 28z equals 28. After I do the operation, right, execute the operation here, is going to give us 2z equals to -2. So here, guys, I can divide both sides by 2 because I want to solve for z, so we get z equals to -1. Now I'm going to back substitute. Okay? This is my equation 1. I can pick either equation 2 or 3, right, to put in here, but I chose the new equation 2. And this is my last equation. We have z equals to a number. Now I'm going to go back substitute. So I'm going to go back to equation 2 and plug in -1 for z and solve for y. So I'm going to go to equation 2. I'm going to plug in -1 for z right here. And then I'm going to simplify. So it's going to give us 4y plus 3y equals -3. I'll subtract -3 from both sides. And it's going to give us 4y equals 0. Right? So we divide both sides by 4. And we found our y value. So now I found my z, I found my y. Now what's missing is what's the value for x. So then I'm going to go back to equation 1. I already know what the y is and what the z is, so I'm going to plug it in here. Okay, so the y is 0, so 0 goes there. And the z is -1, the -1 goes in that spot there. So this will give us x plus x minus 2 equals 0, so we add 2 to both sides, and we found the answer for x. So what's my solution? The solution is 2, 0, -1. This is a point where these three equations meet. Okay, and we have three variables. It means that that's like in 3 dimension. Okay. Now let's see what else is next. Now this is called the Gaussian elimination method. I believe this is one of the well, this is my opinion as a student and also as an instructor. This is perhaps one of the most difficult topics in 1324. Okay, but I have a system that I modified. I have like certain steps or certain procedures to follow, so this will not be as hard. And when I share my modified method, the modified method of the Gaussian method, right? I modified it for it to be student friendly. When I share this with other instructors, with other with tutors and with students, they say that it's easier than the way the book explains it. Okay, and this is not me saying that this is what people give me feedback after I explain the Gaussian method. Okay, so anyway, we have a linear system of equations. We're going to convert it to augmented matrix. Then it's going to be a reduced row echelon form. That's what that means, RREF, reduced row echelon form. Some of you guys might be thinking, well, what is he talking about? Okay, this is linear systems of equations. This is the augmented matrix form. Right, what we do, we only get the coefficients from every variable. You see, we have 1 for x, we have -3 for y, we get 2 for z, and we get 0 for the constant. And in a similar fashion, this is my equation 2, and this is my equation 3. I only get the coefficients. This is considered row 1, 2, and row 3, okay, which I'm going to tell you later. Okay, now the objective is to have it like 1, 0, 0, 0, 1, 0, and 0, 0, 1, right, equals to a number for whatever here. This means that x, because this is like x, y, and z equals to whatever the number is here. So in this case, I have like 1x plus 0y plus 0z equals to 2. In a simplified version, it means x equals to 2. In the second row, y equals to 0, and the third row, it's z equals to -1. How are we going to do that? Okay, now here's my plan. 3-step plan in action. Okay, there's my augmented matrix. Okay, my plan is to have it in reduced row echelon form. And later on, I'm going to show you how to plug this in the calculator towards the end. Okay, so anyway, I do it in 3 steps. This is considered row 1. This is row 2, right? Row 1, row 2, and row 3. That's row 3. So my first step, I want to make that 2 a 0 and the 3 a 0, right? Because the first step, right, is in blue. Everything is color coded. You see, I want to make these 2 zeros. So these 2 must be zeros. When you use step 1, you keep row 1. When you use step 2, you're going to keep row 2. When you use step 3, you're going to keep row 3. So in other words, step 1, row 1 stays the same. If step 2, row 2 stays the same. If step 3, row 3 stays the same. And I'll explain as I go along. So for now, my first step is I want to make the 2 a 0 and the 3 a 0. Right? So that's why I put an arrow here. Because this, I'm going to get a new row for row 2, and I'm going to get a new row for row 3. Okay, now, I'm going to be using row 1. So here, guys, I need to multiply -2, right, times row 1. So when I add it to row 2, they'll cancel. So it's going to be -2 row 1 plus row 2. In a similar fashion, I'm going to multiply -3 times row 1 and add it to row 3. Okay, now here's my work. -2 row 1 is -2 times 1, -3, 2, 0, right, which is here. So after I distribute, I get -2, 6, -4, 0. Then row 2, I just bring it over, right, which is 2, -2, 1, and 3. After I add them, right, it's going to give us 0, 4, -3, 3. So this is considered my new row 2. Now I'm going to do the second part of step 1, which is -3 row 1. I'm going to multiply -3 times every term here. It's going to give us -3, 9, -6, 0. I'm going to add it to row 3, right? Row 3 is 3, 1, -1, 7. After we add them, it's going to give us 0, 10, -7, 7. So this is my new row 3. So on my next slide, I'm going to continue, but I'm going to keep only what's here, and I'm going to show you step 2. Okay. Remember, this is my plan, right? My plan, I already done step 2. So I brought the most important information from the previous slide, which is step 1. Now I'm going to do step 2. So step 2, right? If you see here on top in green, these 2 slots have to be zeros, right? So the -3 must be a 0, and the 10 must be a 0. So remember step 2, I'm going to keep row 2 how it is. And the -3 must be a 0. So that row's got to change. and the 10 has to be a 0, so this row is got to change. Okay, now I'm going to be using row 2. So here, guys, I'm going to multiply 3 times row 2 and add it to 4 times row 1. In other words, guys, since we already have a positive and a negative, this one I multiply by 3 and this one by 4. See, that's what I did here. And over here on the second step, I'm going to multiply this row by negative 10. So negative 10 row 2 plus 4 row 3. Okay. So let me execute the 3 row 2. I'm going to multiply 3 times everything in row 2, right? Which is a 0, 4, negative 3, 3. This is my result. 0, 12, negative 9, 9. And then I'm going to do 4 row 1, which will be 4 times 1, 3, 1, negative 3, 2, 0. Right, so after we distribute, that's my result. So after we add them, it's going to give us 4, 0, negative 1, 9. So this is my new row 1. In a similar fashion, I'm going to execute the second part of step 2, which is part B. So negative 10, right, negative 10 row 2 from here will give us negative 10 times everything in row 2, which is 0, 4, negative 3, 3. So this is a result after I distribute. 0, negative 40, 30, and negative 30. Then I'm going to multiply 4 times row 3. So I'm going to multiply 4 times 0, 10, negative 7, and 7, right, which is right here. And that's my result. So after you do the operation, it's going to give us 0, 0, 2, negative 2. But you always simplify as you go along. So in this case, I'm going to divide everything by 2 because I want that to be a 1, right? I want this lot to be a 1. And since this is not that I know I can divide everything by 2, I'll do that. But if this was like a 7 or like a non-number, I would leave it like this. And then at the end, I will simplify. This way, you don't get no fractions. Okay, everything will be real numbers. I mean, like integers. So it's going to give us 0, 0, 1, negative 1, right? Because if I divide everything by 2, my result will be 0, 0, 1, negative 1. So this is my new row 3. Now, on the next slide, I'm going to have all this, right, on the slide. Then I'm going to show you step 3. Okay? You see, guys, we almost have it in this form, right? We already got these 2 zeros. They come from the ones here in blue. I already have these 2 zeros on the second column, right, which is step 2. Now I need to make the negative 3 a 0 and the negative 1 a 0. But remember, step 3, I'm going to keep row 3 how it is. So the negative 1 must be a 0, so I'm going to change row 1. The negative 3 and the slot here is going to have to be a 0, so I have to change row 2. And how? Is by using row 3. So here, guys, if I add the 1, I'm in row 3 plus row 1, that's going to eliminate the negative 1 there, right? So I'm going to add row 3 plus row 1. And to eliminate the negative 3, I need to multiply row 3 by 3. So it's going to be 3 row 3 plus row 2. And here's my work. Row 3 plus row 1 is going to give us 4008. And here, guys, we divide everything by 4, so it's going to give us 1002. So this is my new row 1. Now, let's do the second part of step 3. 3 row 3, right? So 3 row 3 means 3 times 0, 0, 1, negative 1. This is my result, 0, 0, 3, negative 3. Then we're going to add it to row 2. We just bring row 2 over. So after we add them, it's going to give us 4, 0, 0, right? And remember, since it has to be a 1, we divide everything by 4. Simplify. Give us 0, 1, 0, 0. So, which means this is my solution. 2, 0, negative 1. Okay? Are you guys okay? Do you have any questions up to this point? If you do, raise your hand up, and Patricia will let me know what your question is. So can I move on? If I can move on, please raise your hand up. Anybody else? Okay. Because I don't have my other computer, so I cannot see who's there. Okay. So I'm going to move on, okay? Okay, now this one, I'm going to do it kind of quick, okay? Because I still have like 20 more slides to go. I mean, like 10 more slides to go. Okay, so here, guys, remember, this is the using the Gaussian method to do everything in one page. I'm going to do everything here, guys, in one page. So step one, right? Step one, I'm going to keep row 1. So the 2's got to change, the negative 1's got to change. So this row 2 changes and row 3 changes. So I'm going to use row 1. So to get rid of the 2 there in row 2, I multiply row 1 by negative 2. So it's going to be negative 2 row 1 plus row 2. To get rid of to make this a 0 here, where the negative 1 is in the first column, I just add row 1 plus row 3. And here's my work. Step 1, right? Step 1, this is the A part and the B part. So for the A part, I have negative 2 row 1, which will give us negative 2, negative 4, 2, and negative 12. Plus row 2, right? Until we do the operation, it's going to give us 0, negative 5, 5, and negative 5. Hey guys, if we keep it how it is, it's going to make the work much harder or much more complicated. So instead, we can simplify. And like I mentioned in my last PowerPoint, which was last week, that you always simplify. That's part of the plan. And this way, you always guaranteed to do it at the most 3 to 4 matrix. You see, if you notice, I always have 3 matrices because that's how much it takes. So here, guys, simplify, divide everything by negative 5. So if I divide negative 0 by negative 5, it would be 0. Negative 5 divided by negative 5 is 1. 5 divided by negative 5 is negative 1. And negative 10 divided by negative 5 will give me 2. This will be my new row 2. And for the second part of step 1, I'm going to add row 1 plus row 3. There's my row 1, there's my row 3. So after I do the operation, it's going to give me 0, 1, 0, 1. So that's my new row 3. You guys might be thinking, well, why is this a 0? It's going to be a 1. Do not worry about that. Just follow my rules and you're going to be okay. Okay, because at times students will tell me, hey, Mr. Isasi, well, that has to be a 1 and it's a 0. How is it going to change? And I tell them what I just told you is that don't worry, everything will fit like a glove. So for step 2, right, in green. So for step 2, I'm going to keep row 2 how it is. And the 2 must be a 0, so that's going to change, right? Row 1, and the 1 here on the third row must be a 0, so row 3 is going to change. And we're going to be using row 2. So to get rid of the 2 there, I need to multiply this one, the second row, by negative 2. So negative 2 row 2 plus row 1. And to get rid of the 1 here on the second column, on the third row, I need to multiply the row 2 by negative 1. So it's going to be negative 1 row 2 plus row 3. And here's my work. So negative 2 times row 2, right? Negative 2 times 0, 1, negative 1, 2 is going to give us 0, negative 2, 2, and negative 4. When we add it to row 1, it's going to give us 1, 0, 1, 2. So that's my new row 1. 1, 0, 1, 2. And then I'm going to do the second part of step 2, which is a negative 1 row 2 plus, right, which will give us 0, negative 1, 1, negative 2 plus row 3. And row 3, it stays the same, which will be 0, 1, 0, 1. After we add them, we get 0, 0, 1, negative 1. You see, guys, that was converted to a 1 by doing the operation. So now I've done steps 1 and 2. You see, this is step 1, make 2 zeros. Step 2 is make these 2 zeros. Now step 3, I need to make these 2 zeros, which is a 1 from row 1 and the negative 1 from row 2. And we have to use row 3. So step 3, row 3 stays the same. So the row 1 on the third column is going to change. And row 2, the third column, the negative 1 is going to change. And we have to use row 3. So to make that a 0 by using row 3, we have to multiply negative 1 times row 3 and add it to row 1. To get rid of the negative 1 by using row 3, all we have to do is add them, right? Because negative 1 plus 1 will give me a 0. So we're going to use row 3 plus row 2. And here's the first step. Negative 1 row 3 will give us 0, 0, negative 1, 1 plus row 1. My answer will be 1, 0, 0, 3. So that's my new row 3. I mean my new row 1. In the second part, we're going to add row 3 plus row 2. We get 0, 1, 0, 1. You see guys, all these are 1s diagonally and the rest are 0. So we're done. So what's my solution? My solution is x equals 3, y equals 1, and z equals -1. So that's my solution. And this is one of the hardest topics to explain. But like I mentioned earlier, my modified method is much easier because I come up with a plan and I show you what we do every step of the way. Okay, now let's continue. So how can we apply this to real life? Okay, and I believe I did this problem last week, but I didn't work it out. I just give you guys the answer, but I'm going to work it out right now. Okay, so what's the objective here? It says tickets to a band concert cost $5 for adults, $3 for children, for teenagers, and $2 for preteens. There were 570 people at the concert. The total ticket receipts were $1,150. 3/4 as many teenagers as preteens attended. How many adults, teenagers, and preteens attended? Okay, so what's my solution? I need to find 3 equations. So again, like the before, let's do people with people and money with money, right? And then the second to last sentence will be my third equation. But for now, let's name the people. So we have adults. So let x equals to adults. We have teenagers. Let y equal to teenagers. And we have preteens. Let z equals to preteens. How many were there total? 570. So it's going to be x plus y plus z equals to 570. Now comes the money with money, right? So if the adult tickets was x and there were $5, so this will be 5x. If the teenager tickets were $3 and teenagers is represented by y, that's going to be 3y. In the same fashion, we have preteens, right, were $2, and preteens were represented by z is going to be 2z. What was the total receipts? 1,150. So it's going to be 5x plus 3y plus 2z equals to 1950. That's equation number 2. Now I'm missing equation 3. So equation 3, we get it from the second to last sentence. Okay, we get it from there. So this is a little bit challenging to go from words to an equation, right? But I'm going to show you what's easier. The way it's easier for me. Teenagers, right, is there, and also preteens. Teenagers is y, and preteens is z. This is what it means here, guys. 3/4 as many teenagers as preteens attended. So this is the equation. But at times, it's kind of harder to explain it how it sounds here. So I found a method to make it easier. Okay. If it is difficult, write it how it sounds. Doesn't it sound like 3/4 y equals to z? Right? That's the way it sounds, right? So write it like that, and then I put switch it. I think in the last PowerPoint I put flip it, so I came out with a better word. You switch it. You put the 3/4 where the z is, and you see that's the way it should be. But now you want to put it in ax plus by plus z equals c. So I need to make these right integers. So I'm going to multiply everything by 4. Why 4? That way I don't have a fraction, because it'll be harder to do it with fractions. Now I'm going to subtract 3z to both sides. So this is my third equation. Right, equation 1, 2, and 3. Now, here, guys, I'm going to solve it, okay? But I'm not going to use the Gaussian method because it's a little bit more challenging to do. And you guys need practice in order to dominate it. But I prefer to do it right by solving systems of equations by, remember the plan that I showed you guys, that you're going to get 1 and 2, get rid of the x's, right? So here, guys, I'm going to use equation 1 and 2. I'm going to get rid of the x's. So I'm going to multiply the first equation by -5. Again, why -5? Because -5 times x will give me -5x. Then when I add it to the 5x in the second equation, they'll be eliminated. But I have to multiply -5 times every term. So this is my result. If I multiply -5 times x times y times z and times 570. So equation 2, we just bring it down. So after we do the operation, we get -2y minus 3z equals to -900. And here we cannot simplify, right? Because this can be divided by 2 and also by 3, but the 3 cannot be divided by 2, so we leave it how it is. So this is my new equation 2. Now I repeat the process. But here, guys, right here we don't have an x, right? There's no x, so I don't have to do the next step. So this is my equation 2, and this is my equation 3 here, right? Because again, there was no x. I don't need to do the second step. So now here I'm going to get rid of the y's. So I'm going to multiply the first equation by 2. Why 2? Because 2 times -2 will give me -4. Then when I add it to 4, they'll be eliminated. Okay, so 2 times -2, -3, z, and -900, this is the result. Equation 3, we'll just bring it down. So this will cancel, so it gives us -9z equals to -1800. We divide everything by -9, so we get z equals to 200. Now I have my 3 equations. Now I'm gonna back substitute. So I'm gonna go to equation 2, right? I'm gonna plug in 200 for z, right there. So then I get -2y minus 600 equals to -900. I add 600 to both sides. Then I divide both sides by -2. And this is my result, 150. Now I need to solve for x. So I already have the value for y and z, which is 150 and 200. I'll plug it in for the y and the z. There's my y, 150. My z is 200. Okay, after I simplify, I get x plus 350 equals to 570. Subtract 350 to both sides. So I get 220. So x equals to 20, y equals to 150, and z equals to 200. And I believe the x was adults, the y was teenagers, and the z was preteens. So it's going to be 220 adults at the concert, 150 teenagers, and 200 preteens. That's how you work these type of problems. Okay? All this can be converted to matrix and plug into the calculator, but at the end, I'm going to show you that. Okay? This way, you guys know how to work it by hand. Now comes 6-4. Addition, matrix addition. Okay? This is a 2x3 matrix because you go by the rows first and the columns. So this has 2 rows and 3 columns, 2x3. B is 2x3, C is 2x2, and D is 2x2. In order to do the operations on matrices, they have to be the same size. So can we do A plus B, matrix A plus matrix B? Yes, we can, right? Because these are the same size. So it's going to be the same thing as 5 plus 2, -1 plus 0, 6 plus 1, and 3 plus -3, and 4 plus 1, -2 plus 4. Right, so this becomes 7, -1, 7, +6, 5, and 2. That's my result of A plus B. Or you can go like this, because you can go 5 plus 2 is 7. -1 plus 0 is -1. 6 plus 1 is 7. 3 plus -3 is 0. 4 plus 1 is 5. -2 plus 4 is 2. So you can do it either way. Okay, but I did it this way by showing you everything, guys. That way you know what's taking place. Okay, now can we add C plus D? C is a 2x2 and D is a 2x2. So yes, we can add them. So it'll be 3 plus 2. 1 plus -1. -5 plus 8. And 0 plus -6. So they will give me 5, 0, 3, -6. So that's the result of adding C plus D. Now can we add C plus A? C is 2x2 and A is 2x3. You cannot add them because, or subtract them because they have to be the same size. So not possible. Okay, not the same size. So now again, now I believe this is also subtraction. Okay, now we're going to subtract a minus b. So it's going to be 1 minus 8, negative 3 minus 0, 2 minus 1, 2 minus negative 1, and 2 minus 3, and negative 1 minus 4. And then we evaluate, so it's going to be negative 7, negative 3, positive 1, positive 3, negative 1, and negative 5. So that's a result of A minus B. In a similar manner, let's do C minus D. And again, this can be done because these two are the same size. So 5 minus 2, 1 minus negative 1, negative 4 minus 9, and 3 minus negative 7. So this will be what? This will be 3, 2, negative 13, and positive 10. So that's my solution of C minus D. How about A minus C? A minus C, again, this is a 2 by 3, this is a 2 by 2, so it cannot be done. Why? Because not the same size. Okay. Now, let's do, it says perform the indicated operation. So here we're going to find negative 4a, we're going to do 5b, and negative 4a plus 5b. Here we're going to multiply by a scalar. This is considered a scalar. So negative 4a is the same thing as negative 4 times every element in matrix A. So it's going to be negative 4 times negative 2, negative 4 times 0, negative 4 times 5, and negative 4 times 3. Or if you want, you can skip this step, the middle step. You can go negative 4 times negative 2 is 8. Negative 4 times 0 is 0. Negative 4 times 5 is negative 20. Negative 4 times 3 is negative 12. And that's my result. Now, 5 times b, so we get 5 and we put matrix B there. The 5 and matrix B. So it's going to be 5 times 0, 5 times 2, 5 times 4, and 5 times negative 6. So it's going to give us 0, 10, 20, negative 30. So now they're doing negative 4a plus 5b, right? I already found negative 4a. I already found 5b. So let's do the operation. Negative 4a, right? I got it from what I did on part A. Plus 5b, I got it from part B. So this is going to be 8 plus 0, 0 plus 10, negative 20 plus 20, and negative 12 plus negative 30. The result is going to be 8, 10. This will be 0, right? Because negative 20 plus 20 is 0. Negative 12 plus negative 30 will give us negative 42. That's my result. Okay. Now let's multiply matrices. To multiply matrices, there's specific roles that are going to take place. For example, B times A, right? We're going to put B first because B is first. So B is a 2 by 2 matrix, and A is a 2 by 3 matrix. If the inner numbers are the same, yes, it can be done. Yes, it's a match. They can be done. And the answer will be the outer numbers. Right? It's going to be a 2 by 3 matrix. So you always check first if it can be done. If the two numbers in the middle and here like in the middle, if they're the same, if it's a match, you can do the operation, and the solution will be the outer numbers 2 by 3. Okay. Now here's how it's done. Step 1. So I put B, right? I put the first row in blue for a purpose, so you guys can actually so it'll be more visual. And then I put matrix A, right? I put it second, but I put him in red because I'm going to multiply the first row, which is 1, 0 times every column. So negative 1 times 2, 0, and then plus 0 times 4. So the answer will be 2 plus 0. The answer is 2, so 2 goes there. Step 2. I'm done, right? I'm done with the first column. Now I'm going to multiply again the negative 1, 0. I'm going to multiply times the second column here, right? Which is this column here, column number 2. So -1 times 0, 0 times -2 is going to give us 0 plus 0. The answer is 0. So the 0 goes here in the second slot. Step 3, right? Now, for step 3, the 5 and the -3 is going to be in red, because now I'm going to multiply this row, first row, times the last column. So 1 times 5 plus 0 times -3 is going to give us 5 plus 0. The answer is 5. So the 5 goes on that slot right there. So I'm done, right? I'm done with the first row times every column. Now, right now comes step 4. Now we do the second row. That's why I put it in blue. And we're gonna repeat the process as in step 1. So column 1 is going to be in red, because now I'm going to multiply the second row times the first column, and then the second column, and so forth. So 4 times 2 plus -2 times 4. The answer is 8 minus 8. It's going to be 0, so the 0 goes on that slot there. Step 5. Right, I'm going to get now I'm going to multiply them times the second column. So 4 times 0 plus -2 times -2. So it's going to be 0 plus 4. The answer is 4. So the answer goes right there. Now comes the step 6, which I'm going to multiply the second row times the last column, which is a 5 and -3. That's why they're in red. So 4 times 5 plus -2 times -3. So it's going to give us 20 plus 6. The answer is 26. So 26 goes there. And that's how you solve. That's how you multiply this matrix. There's my solution. Okay? You guys okay? Okay, so I'm going to continue. Now comes find the inverse. So for the inverse, okay, the inverse, like you multiply matrix A, right? So to find the inverse, it's going to be a little bit more, right? We're going to use the Gaussian method. So in other words, I'm going to have to make these two have to be 0. In other words, the identity must come to the left, and whatever's on the right is going to be my inverse. Use Gaussian method, right? So this is my inverse, because the first step was to make that a 0. Second step was to make that a 0. So this is my inverse. Okay, now. So I believe here's how it's done. Row 1 and row 2. I'm actually going to show you here. So this has to be a 0, correct? So I'm going to multiply -4 row 1 plus row 2. And again, remember step 1, row 1 stays the same. Here's my work. -4 row 1 is going to give us -4, -8, -4, and 0. Now I'm going to add it to row 2. It's going to give us 0, -2, -4, 1. So that's my new row 2. If you notice, I already made that a 0. Now my second step, that has to be a 0. So I'm going to use row 2. That 2 on top is going to change. So I'm just going to add them. Row 2 plus row 1. Right? And remember step 2, row 2 stays the same. And here's my work. Row 2 plus row 1 is going to give us 1, 0, -3, 1. That's my new row 1, right? So these two are okay, but this has to be a 1 there, right? Because remember, this was the inverse, right? So we got 1, 0, 0, 1. We have 1, 0, 0, -2. So the -2, which is the second row, is gotta be a 1. So I'm going to multiply by -1/2 times every term. So I get -1/2 times 0 will be 0. -1/2 times -2 will give us 1. -1/2 times -4 will give us 2. And -1/2 times 1 will give us -1/2, right? You see, guys, this is my inverse. That's how you find the inverse. Okay. Okay, now, you can find the inverse another way. Okay, this is a formula to find the inverse of a 2x2 matrix. Okay, it only works for a 2x2. So the inverse will be 1 over the determinant, which will be A times D minus B times C. And then the A and the D, you switch places. You see my D goes there, my A goes there, and for the B and C, you switch signs. This is my formula to find the inverse of a 2x2 matrix. Okay, let's find the inverse. I believe that was the same problem as before. I'm not. I think it is okay, but let's find out. So the answer will be 1 times 6 minus 2 times 4. Right, and then the 6 and the 1 we switch them. You see, the 6 goes to that spot, the 1 goes there, and the 2 and the 4, which are on the slot of B and C, we switch the signs. Remember, this was 1/2, right? This is because 6 minus 8 is negative 1/2. So we multiply negative 1/2 times every term. We get negative 3. We get 1. We get 2, and we get negative 1. That's my inverse. And this is how you find the inverse, which I believe is easier than using the Gaussian method, what I did on the previous slide. So this is my result. Okay, now here's how to plug into the calculator, okay? If you happen to have a TID3 calculator with you or a TID4, please take it out. Okay, so to plug into a matrix, right? You're going to go to second, then you're going to hit matrix. Matrix is the key where you have the, let's see, matrix, or where you have the inverse key, which is x to a negative 1. That's where it says matrix. After you do that, okay, I'm doing it here as I go along. After you do that, you're going to go down to edit, right? You're going to go to edit. So you go like 2 slots, you're going to go to edit, and then you're going to enter. Now you're going to enter the size of the matrix, right? So you're going to put the size of the matrix, and afterwards you're going to, after each entry, you press enter. So you're going to press, you're going to enter every entry on the matrix. After you do that, you're going to go to second quit. Your screen should be dark, or I mean, second quit is the key is the mode key. After you do that, the screen should be blank, which means that matrix that you just inputted is there like in a filing cabinet. It's there. It will always be there unless you take it out or you clear your calculator. Okay, now if you're solving, right, if you're solving the system, then you go again to second matrix, and then you're going to go to math. Then you're going to go down to RREF, which means reduce row echelon form. Then you're going to get the matrix, which most of the times is going to be the first matrix, which is matrix A. You're going to enter, then you're going to go second, get the matrix, choose the matrix B and solve, which is mostly is the matrix A. You enter it, and you get your enter, and you get your answer. After you close parentheses, you get your answer. Okay, now that's it. The matrix was a 2 by 3, right? If it was a 2 by 3, this is what you would see on your calculator. If it was a 3 by 4, then you will see 1, 0, 0, 0, 1, 0, and 0, 0, 1, like we did when we solved the matrix with 3 variables. Okay, now, but let's pretend, right? So the answer will be x equals to A and y equals to B. Now let's pretend that if you want to store the matrix in the calculator, you stop, and then you repeat the process from the beginning to enter additional matrices. Be careful, do not use the same location to enter additional matrices. So for example, if you already use matrix A, so you go to matrix B. And this way, you can actually just go, you can add, you can subtract, you can divide, I mean not divide, you can add, subtract, and multiply here on the calculator with the matrices. This is to check your work. But most instructors, including myself, we want to see the work that you did it right, and you can use the calculator to check your results. Okay, now let's solve. I believe I have like 2 more slides. Solve the matrix equation using AX equals B. So solution. My solution will be x equals to the inverse of A times B. So we need to find the inverse of matrix A and multiply by B. Using the inverse formula, right, for a 2 by 2 matrix, you get, this is what we get. Right, using the formula. So this is the inverse. After you apply that, this is what you should get. Okay, so now I'm going to multiply this times matrix B. This is matrix B. 2 by 2, 2 by 1, right? It can be done, and the answer will be a 2 by 1, right? That'll be the answer will be a 2 by 1. 2 by 1. So let's start here, right? So it's going to be negative, right? So negative, it will be 5/3 times negative 3 will give us negative 15 over 3. Plus negative 2/3 times 5 will give us negative 10 over 3. If we add them, it's going to give us negative 25 over 3. So that goes on the first lot. Now we do the negative 1/3 times 3. Will give us 3 over 3. And then we're going to add 1/3 times 5 is going to give us 5 over 3. The answer will be 8 over 3. So that's the solution for the second part. So this is x equals to, let me go back real quick. Let me go back here. Yeah. So let me start from the current slide. So let me go real quick. Right, this was the answer for the first lot will be the answer for x and the answer for y. Right, it's saying, right, the x was this, right, this is the answer for x and y, right, but the matrix x means this is matrix A, which means x equals to negative 25 over 3 and y equals to 8/3. Okay, now, how do we use this like in a real life problem? Okay, so let's do it, and I believe this will be my last slide. Solution. Let x be number, okay, but first, let me read the problem here. It says, write a system of equations and use the inverse of the coefficient matrix to solve the system. Budget truck rental charge $19.99 per day plus 59 cents per mile to rent a 12-foot moving truck in Austin, Texas. Okay, now let me continue. The total bill for your move was $86. The rates for a local moving company were $10 per day and 95 cents per mile. And the bill for the same trip would have been $94.10, right? Which is a little bit, it's about $12, $8.10 more. So this is equation 1. Okay, let the days be x be the number of days and y be the number of miles. So I'll be 1999 x plus 0.59y equals to 86. For equation 2, it's going to be 10, and that'll be my x, that'll be my y, and that'll be my constant. So I'll be 10x plus 0.95y equals to 94.10. Okay, now for the inverse. For the inverse, right, there's my right there, right? There's my 1999, 0.59, 10, and 0.95. My x will be x and y, and my b is going to be 86 and 94.10. Right, so for the inverse, right, use a calculator to find the inverse. How do you do that in the calculator? All you do is go to second matrix, right? You're going to go to enter a 2x2, it's a 2x2 matrix. You enter all these entries, and then you go to second quit, and then you go to the A inverse, right? You hit the inverse key, and it'll give you the matrix. So that's the inverse of matrix A. Okay? And if you want, you can go back to the previous slide and actually use the steps how to input it into a matrix. And B is 86 and 94.10. So right? So the answer will be 278. And how do we get that? Because I multiplied 0.073 times 86, and then you add it to negative 0.045 times 94.10, and it's going to give us 2. And in a similar manner, I multiplied negative 0.764 times 86. Then you're gonna add it to 1.527 times 94.10. It's going to give us 78, which means x is days and y is miles. So the trip was 2 days long and 78 miles. That's your result. Okay. Okay. Now questions. Hey guys, are you guys okay? Do you have any questions? And like I said, guys, this is only like a review, guys. Most of the material you guys should have been exposed to it already. Okay, but anyway, if you want a copy of this PowerPoint, you send me an email at aesasi@epc.edu, and I'll be more than happy to send you the PowerPoint. If you guys need help, you join my Sunday numbers. Sunday numbers, I tutor every Sunday, and I believe Patricia has the link. You can join me. It has specific time for specific topics, and I can help you. Also, guys, I do this every semester. every Sunday it's a different, different hours, but I always try to help, students out on Sundays. Okay, let me stop let me stop me sharing. That way, let me go here. How can I stop this? Let me go here.
Thank you, Mr. Azasi. So while I have everyone still here, I would like to invite you all for next week. Let me see, is this the right one?
There we go. Yeah.
Okay, there we go. So next week at 1 o'clock at the TVE link, we're going to be having the PASOS program and the Diversity and Inclusions program come give us their presentations in their department. And then in Math 1314 at 3 o'clock, we will be having basic matrix operations and using matrix operations. As well as in Math 1324, we'll be here for sets. Now, Mr. Azasi had mentioned Sunday numbers. Well, Sunday numbers is a part of our OLA guide, our online assistance guide. And it shows all the different tutoring providers. And if you look here at the bottom, we have the link for Sunday numbers. And you can see that the time for Math 1324 is 9 a.m. to 10 a.m. on Sunday. And there's the link. Let me give you the link to download our OLA guide. Give me just a second. Here it is. Copy. All right, and then I'll put that in the chat for you if you're interested in the OLA guide, as well as I did put Sunday's numbers link directly to their Blackboard in the chat. We hope to see you at Sunday numbers. It's a pretty awesome thing, I have to say, Mr. Azasi. And we wish you good luck on your exam 3 exam this weekend. Thank you for coming, and I hope you have a wonderful day.